analytical science over a period of more than 45 years at various multinational companies like Piramal, Unilever, Searle India, after obtaining a PhD in physics from the University of Madras. He has more than 700 publications and 7 patents to his credit. He has written more than 100 articles or 500 pages of technical notes in SWNCO's Cutting Edge Journal for more than a decade under the title Sharing the Learning. Dr. Venkat is also a distinguished speaker and an invited guest for various trending seminars from the industry, as well as from many, like regulatory bodies like FSSAI and IP, etc. He even gave a talk in CPHI, which was actually conducted in Europe. And this was on the very, very trending N-nitroso impurities. This month's Sharing the Learning is all about mass spectrometry, the gold standard for testing, as it offers better sensitivity, selectivity, even for trace substances at extremely low concentrations. The mass spectrometer, especially the triple quadrupoles, can be effectively used both for qualitative as well as for quantitative analysis, helping us to identify, to characterize, and to quantify. Hence, mass spectrometer has become the first principal detection of choice in various fields such as pharma, and I'm sure there is no one here who would not have escaped the wrath of the N-nitroso impurities, biopharma for all the omics-based applications, clinical and diagnostics for the vitamin panels, personalized medication, food for all the multi-residual pesticides in all the food that we eat, and also for environmental testing for the toxicology estimation. And then we have the automobile industry, the chemical testing. Hence, it is paramount to uncover the basics of mass spectrometry, the science behind mass spectrometry, to understand the intricacies of its operation so that we can unleash its full potential. Today's webinar, Dr. Venkat Manohar will take you on a tour, not on a leisure tour, but a scientific one of the different components of the mass spectrometer, discussing on how optimizing these parameters can give you robust results. Before we start, I'd like to go over some house rules. Please use the Q&A box only at any time to log in your questions. Dr. Venkat Manohar will answer them once the session is over. Without much further ado, over to you, Dr. Venkat.
Thank you, Janani, for your nice introduction of mass spectrometry as well as about me. I will first share the screen. Is the screen is visible? Is it okay?
Yes, sir. You can go.
Okay. Good afternoon, all the participants. I am very glad there are more than 250 people are attending this seminar, and this itself shows the importance of mass spectrometry today in our various aspects of analysis and various kind of applications. There is not even a single area left out in science without doing a mass spectrometry analysis. Whenever and in the irrespective of various kind of technology available before us, mass spectrometer or a mass spectrometry technique is considered one of the universal technique for any kind of applications, and it gives an answer and a kind of clue, some kind of input to various applications and to almost many aspects of science. Today, I am going to introduce you mass spectrometry as a device or basically a detector to chromatographic techniques. Initially, in the last 4 seminars, when I was talking to you all about various kind of aspects of HPLC, then I also discussed about the requirements of a detector. I discussed all kind of detectors and I gave a small introduction to mass spectrometry. After seeing the number of participants, after seeing the overwhelming enthusiasm among the participants, I shall once again introduce mass spectrometer from the beginning. Today's presentation, what we have decided is, we not only talk about how to connect a mass spectrometer with a liquid chromatography, but also how to connect with a gas chromatography. Gas chromatography or a liquid chromatography, both will act as a sample introducing device in a mass spectrometer. Though there are several kind of detectors available with these chromatographic techniques, mass spectrometer has got one additional advantage compared to all other detectors. The advantage is it gives information about the compound that we are under investigation, the analyte under investigation. What does it do is, it will tell you what is the compound is, how much it is. All this information will give. When it gives information how much it is, it can go down to very, very low level, not PPT, not PPQ, at autogram level, 10 power minus 21 grams, very close to Avogadro's number, is able to give you the information to you. So that is the power of this technique. Therefore, we shall discuss this in detail. How does it do? Therefore, in my presentation, the whole presentation, I am going to take you inside the mass spectrometer. At the end of the day, you'll be able to see how your mass, your compound or your analyte is getting recorded or understood in terms of a mass spectrum that you get out of this device. Okay, with this brief introduction, I will define to you what are the various kind of detectors people use and what kind of the expectation from the detector. Any detector that you use for a gas chromatography or a liquid chromatography, it should have high sensitivity. It should have baseline should be completely noise free, and then it should have a large dynamic range. The response of the detector should be independent of the parameters of the detector, and then such as pressure, flow rate, etc., mobile phase composition, temperature, all other parameters. And the dead volume should be very low. And above all, and the operation of the detector should be stable over a long period of applications. And irrespective of whatever happened, you should be able to give a consistent result. Therefore, and above all, simple and reliable to operate so that you or anybody can operate the instrument. Mass spectrometer belongs to this category. Though we can classify detectors in several forms, I will focus today only on the mass spectrometer. What is a mass spectrometer? Very, very simple device. The mass spectrometer basically consists of a source which is able to generate electrons. After the electrons interact with your analyte or the compound I use the word compound, which is easy to follow. After the electron interacts with your compound, it produces ions. Those ions are analyzed and then detected. Therefore, basically, a mass spectrometer consists of 3 components. One is called source, second is called analyzer, third is called a detector. When a source produces an electron beam and interacts with your compound, the compound becomes an ion, a charged particle. If it becomes a charged particle, the charged particle cannot remain in atmosphere because it will produce electrical discharge. Therefore, any ions that has to be produced, they have to produce under high vacuum. Therefore, the entire mass spectrometer components, namely source, analyzer, detector, everything should be housed under vacuum. Vacuum means how much order, or the order of 10 power minus 6 star. Therefore, you use a rotary evaporator, you also use a diffusion pump or a turbomolecular pump, because it gives you high vacuum of the order of 10 power minus 6 star within a short span of time. That is why the source, analyzer, detector, everything is kept under high vacuum. Therefore, a mass spectrometer where ions are produced basically require a high vacuum unit. High vacuum should be supported by a low vacuum. That's why there's a rotary pump. Okay. Now, if you remember, a liquid chromatography or a gas chromatography, in order to carry the sample inside a mass spectrometer, what you need is, you need a mobile phase. In the case of liquid chromatography, the mobile phase is a liquid. In the case of a gas chromatography, the mobile phase is a gas. Now, the sample or your compound comes along with a mobile phase. Can be liquid or a gas. Whereas the mass spectrometer works under high vacuum. If a liquid or a gas enters in the mass spectrometer along with your sample, immediately the vacuum will come down. The vacuum will get spoiled. Then you cannot operate the mass spectrometer. Therefore, what we should do? You have to remove the mobile phase. Okay, whether it is a gas or it is a liquid, you have to remove both of them. Further, what do you need? You need an interface. Therefore, if you want to couple a liquid chromatograph or a gas chromatograph with a mass spectrometer, you need to use an interface. What is the job of an interface? Very, very simple. The interface should remove the mobile phase. That's all, nothing else. When it removes the mobile phase, what does it do? It will increase the concentration of the sample. Therefore, what you are trying to do, you want to enrich your sample. Therefore, if you look at the criteria for the mobile interface, you should minimize the carrier gas or the mobile phase. Second thing, you should enrich your sample. Third thing, that is not sufficient. The most important thing is your sample may be a solid, may be a liquid. It has to convert into a vapor phase. Under a gaseous phase only, you can convert the molecule into ion. What is ion? We'll see now. Therefore, just 3 jobs. The interface does 3 jobs. First thing, it minimizes. In an ideal condition, if you take a ratio, sample divided by mobile phase, the ratio should be infinity because mobile phase should be 0, whether it is a gas or a liquid. Good, very good, very good. Now, the second thing is, once a sample is enriched, it has to become a gas. Therefore, you should convert in the form of a vapor state. That is why transfer of the sample in the vapor phase inside the mass spectrometer. This is the job of an interface. How does it do? Let us see. Now, let me first to start with, I will start with a simple interface. The simple interface, how to connect a gas chromatography with the mass spectrometer. Why I take it simple? Already the sample as well as the carrier both are in the gaseous phase. Why? The gas chromatography, you inject your sample in the form of a solution, but injector port temperature is so high, what happens is your sample instantaneously goes into the vapor state. Because it goes in the vapor state, the carrier gas, namely the helium, carries your sample straight away in the vapor phase. Therefore, you can take your sample inside the mass spectrometer in the vapor. 2 jobs is done. First thing, gaseous state. Second thing, I am carrying the sample in the vapor state. Excellent. Very good. Now the thing is, I have to remove the mobile phase. How to do that? Very simple. We use several kind of interfaces for that. There is interface called effusion type interface in the gas chromatography. Another interface called membrane separator in the gas chromatography. The third one is called jet separator in the gas chromatography. The fourth one is called hot transfer lines. The first 2, effusion type and membrane separator, are of historical importance. We will not focus on that. Jet separator we will discuss. What is a jet separator? Very simple. If you look at very carefully here, what I have done is, the black ones, if you see, is my carrier gas, helium. I have, my sample is coming in the red color. Now, I have a jet. Jet means very small, fine orifice. My sample, along with the carrier gas, is entering into this jet. When it comes here, at this point in time, where the diameter is extremely low, in this picture, I have expanded the orifice more than 1,000 times. It's a very, very capillary tube, very small diameter. And it comes out when the carrier gas at some flow rate comes out of this, it suddenly undergoes a large expansion. Your helium gas, the carrier gas, being a low molecular substance, undergo larger expansion. Your compound, whose molecular weight is very large, will not undergo that much expansion as that of a helium. Therefore, what is happening is, under this jet separation, what is flowed through this small orifice, the helium, which undergoes a larger expansion, is pumped off by a vacuum unit. Your sample, which goes into the another capillary, kept very close to this exit line, thereby the molecule or your compound reaches into the mass spectrometer. So, using the jet separator, I am able to remove the helium gas when the flow rate is very large. Very, very simple. The jet, because of the molecular weight of helium is low, it undergoes a larger expansion compared to your sample. Therefore, sample is able to pass through in the mass spectrometer, where the carrier gas is minimized. Excellent. No, sir, I am using capillary GC. My column length is 30 meter length, 40 meter length, 60 meter length. Therefore, on the other hand, what I have is my flow rate is very, very small, 0.2 ml or 1 ml. What I will do? Very simple. Use a hot transfer lines. What does it do? It is a special type of fused silica lines kept at high temperature. The carrier gas flow rate will be very small. Straight away it can enter into the mass spectrometer. So then the helium gas will spoil my vacuum? No, because the pump efficiency is so high, the amount of helium entering into the mass spectrometer is so low, it does not disturb the vacuum. Flow rate is very low. Number one. Number two, the helium ionization potential is more than 12 electron volts. Therefore, it is very difficult to ionize the helium gas compared to your molecule. Therefore, helium will not interact. Therefore, it will remain as a neutral molecule. Therefore, the compound alone will go. Helium does not interfere in recording the mass spectrum of your compound. Thereby, you eliminate the influence of the carrier gas. Thus, the hot transfer lines are nowadays used commercially in many of the gas chromatography cum mass spectrometry. Very good. Fantastic. All capillary diseases. Very good. Sir, this is fantastic. But you have been telling the last 15-20 minutes how to enrich your, how to carry your sample inside everything. But you are not telling me what is a mass spectrometer. I am able to hear this question. Very, very simple. What is a mass spectrometer? I will answer you. I have already answered. I have shown an example. An example which I am using the last 25, 28 years. I do not get an example better than this. I once again use the same example for the larger number of new audience who have joined with us today. Okay? You see here. This is a glass tumbler. You take a stone, hit this. The tumbler breaks into pieces. It makes into so many pieces. Oh, one more piece. Oh, one more. But you are a very patient chemist, scientist. You patiently sit, assemble, get back the tumbler. That's what a mass spectrometer is. The stone is nothing but a beam of electrons. The tumbler is nothing but your compound. If a beam of electron bombards the molecules are fragmented into ions as the tumbler breaks into pieces. As you assemble back and get back the tumbler, if you read the mass spectral pattern, you get back your compound because the mass spectral pattern is the characteristic of your compound. If a beam of electron bombards the molecules are fragmented into ions. The fragmentation pattern that you get is the characteristic of your compound. As you get back the tumbler, you get back your molecule. That's what a mass spectrometer is. The beam of electron is generated by the source. All the ions are picked up by are analyzed by the analyzer. And then what you do is you get back your compound by recording it using electron multiplier, a detector. All these happenings inside the vacuum now. Let us see how does it do. Because I am using electron beam to ionize my compound, I call it as electron ionization. What does it do? My molecule is there. The molecule, what I am trying to do, when the electron beam hits, it knocks off the electron from my molecule. The moment my molecule loses an electron, I call it as molecular ion. This molecular ion further undergoes a fragmentation. I get a fragmentation ion, and I also get a neutral fragment. This fragmentation ion is the characteristic of a compound. Since I am using electron, I have to ionize my molecule. This technique is called EI, electron ionization technique. People have used this technique, and also it has got highest sensitivity, can go down to PPT level, parts per trillion level and below that. Excellent. Sir, if that is the case, I am working on an unknown molecule. When I am working on an unknown molecule, how I will get the information? Because I do not know, because this is the molecular ion or this is the molecular ion. What is that? If I get only the fragmentation, don't worry. Very simple. Because the mass spectrum is the fingerprint of your compound. Excellent. How does it do? This is an inlet coming from the gas chromatography. This is the filament which generates the beam of electrons. The compound encounters the beam of electron, it produces a positive ion. The moment it produces a positive ion, it is a charged particle. It forms, any charged particle, if it travels, it forms a current. It's called ion current. When ion current comes here, I use some lenses, apply some voltage, produce the ion beam. I use a trap, I use a repeller, all these things I use. This is a block diagram of the electron ionization source. Okay. Now, I do not know whether I have used the molecular, the fragmented ion I got is a molecular ion or something else. I do not know. If that is the case, is electron ionization the best technique? No, it's a complementary technique. You have one more technique called chemical ionization. What does it do? Very simple. You make the ionization soft. What do you mean by soft? See, you introduce a foreign gas. Maybe methane, ammonia, isobutane, along with your compound. The green dot is nothing but a say methane gas. This is your compound coming red dot. Now both encounter beam of electrons. When both encounter the beam of electrons, the energy of the beam of electron is being shared between your compound as well as the gas that you have introduced, isobutane or a methane gas. It may spoil the vacuum. The vacuum, if it is of the order of 10 power minus 6 star, it may come down to 10 power minus 5 star. By a factor of 10, it can come down. You have to introduce only that much concentration inside the mass spectrometer. Because the 10 power minus 5 vacuum is still sufficient for ionization purpose. Therefore, what happens? The ionization becomes soft. When it becomes soft, this also produces the positive ion. This also produces a positive ion. Therefore, some proton may be left out. Your compound may be enriched. There can be an ion-ion interaction, because of which your compound will be enriched by 1 proton unit. If it is a 265, it will become 266. If it is a 312, it will become 313, M+1 ion. That's what you get out of this. Now, this is soft ionization. The common reagent gases use methane, ammonia, isobutane. It has got high proton affinity and low heat of transaction. Therefore, it will get protonated. If Ma is my molecular analyte, then Ma plus H become my compound, my ion, M plus 1. This is 266, this will become 267. It's a soft ionization. Therefore, if I am not able to see the molecular ion in electron ionization, I can see the ionization of the compound in chemical ionization because I use a chemical gas. Very good. Sir, if I don't see in chemical ionization my molecule, what I will do? Don't worry. We have two more methods called field ionization technique, field desorptionization technique, field fast atom bombardment ionization, FAB it is called, FD it is called, FI called. There are other ionization techniques that are available where you apply electrical field or use a fast atom to heavy atom to bombard your molecule. You can still make the ionization soft. Therefore, there are several methods by which you can do ionization, get the molecule identified. I will show an example. This is a compound called ephedrine. Molecular weight is 165. I have done electron ionization. 165 is not at all seen. I have done chemical ionization, isobutane. I am able to see 166 clearly. I have done field ionization. I am able to see 166. I have done field desorption technique, FDI. I have seen 166. You see, molecular ion is identified by one of these techniques. You cannot escape. This is how mass spectrometer, electron ionization, chemical ionization, field desorption, field ionization, and all these kind of techniques are available at your fingertip, and you can get your molecular ion identified, which is not possible with any other detector at a concentration of PPT level, parts per trillion level, at such a low concentration. Is it possible for me to identify the compound? The answer is yes. You are able to do that. Fantastic. See, there's a small difference between liquid chromatography and gas chromatography. You know very well. What is the difference? In the case of a gas chromatography, you use a gas area as a carrier. In the case of a liquid chromatography, you use a liquid as a carrier. Therefore, when you are going to connect a liquid chromatography with the mass spectrometer, you have to do one more job extra. What is that? Convert the liquid into a gas. Therefore, the job of interface in the case of a liquid chromatography is one more. One more is convert the mobile phase into a liquid into a gas along with their compound, and then remove the gaseous gas molecules of the liquids of the mobile phase in the form of a gas. Then enrich your sample, do ionization. Therefore, the gas chromatography interface does 3 jobs. Liquid chromatography interface does 4 jobs. Very simple. How to do that? Very simple. Evaporation of the mobile phase, enriching the sample liquid to gaseous phase, and convert the mobile phase into a gas. For example, 1 ml per minute flow rate of a liquid in a liquid chromatography is equivalent to 1.2 liter of a gas. The movement to convert into gaseous worker. You have to efficient pump. That is why in liquid chromatograph, we always prefer to use a turbomolecular pump so that it sucks all the vapors very fast. Good. You know, the beauty of liquid chromatography mass spectrometry is the ionization and the interface are simultaneously done. Are done simultaneously. The second most important thing is it's a mild ionization, soft ionization. Therefore, you are able to see your compound intact in most of the analysis. Sometimes you see in the form of an adduct also, depending upon what kind of mobile phase you are using. So, can I use any mobile phase? The answer is no. You have to use only volatile mobile phases. Therefore, the method development for liquid chromatography cum mass spectrometry is a little different from your conventional liquid chromatography. The conventional liquid chromatography, I may use a potassium dihydrogen phosphate buffer or a sulfonic acid buffer or an ion pair reagent. Here you cannot use those things. Here you have to use volatile buffer, acetonitrile, methanol, formic acid based buffer, acetic acid buffer, citric acid based buffer, ammonium formate, ammonium acetate, like that you have to use. Like that you have to use. Volatile buffer is a must. If you have got a method, your US pharmacopoeia says, or Indian pharmacopoeia says, potassium dihydrogen phosphate has to method to be used. Convert that equivalent volatile buffer method for using in the liquid chromatography cum mass spectrometry. It is possible. A table is available. When we see the application method development, I will explain all those things in detail. The beauty of liquid chromatography mass spectrometry is ionization, interface, all done simultaneously by two well-known techniques. Electron spray ionization technique. Another is called atmospheric pressure chemical ionization. Sir, you said when you begin your lecture that you can do any compound analysis, universal technique. The answer is yes. Why do I say it is not only applicable only to small molecules, pharmaceutical, pesticide, it is applicable in large molecules such as proteins, oligonucleotides, oligosaccharides, polymers, all kind of molecules. Mass spectrometer can analyze right from 100 Daltons to a few hundred kilodaltons. Further, what I will do, I use another ionization technique called, another soft ionization technique called matrix assisted laser desorption technique called MALDI-TOF mass spectrometers. Because of all this technology available before you, there is no compound that goes unidentified by mass spectrometer at such a low concentration. Excellent. How to convert the liquid into a vapor? For that, the liquid flows, you have to convert liquid flow into small droplets. When you convert into small droplets, you can reduce the size as low as possible. You produce a mist. When you produce a mist, you evaporate the solvent, the size is getting reduced, therefore it is ready for ionization. Sir, what is this? I am not able to understand what you are saying. Can you explain me much a little better? I will show an example. Very simple. This is your LC. Every day our gardener does this. He takes a hose. You can see the water is flowing. How to convert this mist into the form of a mist? Very simple. Put a hand there. Just put a hand. You produce a mist. This is what is happening exactly in the mass spectrometer. We use when the liquid mobile phase is coming from the liquid chromatography, we use what is called the nitrogen gas at the rate of 10 to 15 liters of flow rate. Thereby, it converts this into the form of a mist, a large number of small droplets. Can you show me? I will show you a picture. This is a mass spectrometer. This is the interface. This is where the liquid is coming. Your mobile phase is supposed to come. Nothing is seen here. Now you see here, a spray mist is coming. This is actually in our laboratory, our LCMS 8045, we have seen such a mist. We have taken a photograph to share with you how you can. This process of producing the mist is called nebulization spray. It is called nebulization. That's all. Very simple. So nothing to worry. Spray mist you produce. Once you produce a spray mist, you evaporate it. When you evaporate it, you produce ionization. That is why, how do you produce ionization? I will show you now. Very simple. It involves 6 processes, 6 steps. First step, produce what is called charged droplets. When you produce a droplet, charge it. Put some potential there. Afterwards, what you do? You reduce the size of the droplet by shrinkage of the charged droplets by evaporation. Very good. Then repeat that, and repeated droplets do disintegration. Once you do one, at a particular stage, a Coulomb explosion occurs to tear the droplet. When a droplet is traveled, then it becomes a gas phase ion production. When this happens, it modifies depending on the atmosphere and sample region. You want a picture to understand this? I will show you. I will take one droplet. This is one droplet. This is my sample. I charge this droplet. A positive potential is created here. You start evaporating this. The size of the droplet is getting reduced. Then further reduce this. When you reduce the size at a particular stage, the charge density becomes very large. When this charge density becomes very large, compared to the potential electrostatic interaction between your compound and the mobile phase, the droplet completely opens. When it opens, the dissolution, the solvent is completely removed, the charge is completely transferred to your molecule. This transfer is what is called protonated ion. I have transferred the charge to the ion. Where is it happening, all this? This is the source. This is the needle through which a liquid sample is coming. I have kept 2 cylindrical electrodes. Now, when the cylindrical electrode is kept, the droplet is coming at some flow rate 1 ml per minute. I am putting a drying gas. I produce here the nebulization. At the simultaneously, I am charging the droplets. Now, because of the drying gas, what is happening is the entire mobile phase is completely removed. Ionization and mobile phase removal are occurring simultaneously in this region. Now, the charged droplet comes here through the skimmer, it enters into the mass spectrometer. Excellent. If I do this under atmosphere, I call it as atmospheric pressure chemical ionization. Same concept. You can use for various kind of applications. Okay. How does it do? Let us not discuss about it in terms of words. I will show you a picture. You can understand much better. This is a liquid gas. This is a nebulizer gas. I produce a droplets. I use a makeup gas where temperature is more than 150 degrees centigrade. My droplet, I produce my compound vapor in the form of a gaseous state. What I do is I keep a rod. At the tip of the rod, I produce very large potential of the order of 6,000 volts per centimeter length. When such a large electric potential is created here, electrical field is created sufficient enough to charge your molecule as well as your water molecule. When both are charged, there is a proton transfer occurs, the compound becomes M+1, MH+. Those things which do not encounter these things, they all escape because I use nitrogen cation gas. All this happening at the atmosphere, therefore it is called atmospheric pressure chemical ionization technique. Very simple. Good. Now what happens? Can I do the different forms? Yes, you can do a little bit differently. Don't use electrical charge to charge the surface. Use laser. Laser is the middle light. Layer photons. Use a photon. So using electron, use a photon. When you use a photon, we call it as laser. What does it do? It tries to remove the knock of the electron, so distortion takes place. Therefore, this ionization. To do this, what we need? I need some matrix. The matrix assists the photon to produce a distortion ionization. Then connect with a detect analyzer called time of flight analyzer called TOF. How does it work? Very simple. Laser distortion ionization. There are several. You can use UV light. You can do IR matrix. You can use surface enhanced laser. All these things you can use, and it is called Seldi technique. And what is the distortion means? Release from an adsorbed state. What is adsorption? Addition of the atoms. That's all. Dissolve it. Fantastic. Now, when you do this, how does it do? It generates a proton from the matrix. When you generate the proton from the matrix, the laser energy is sufficient enough to facilitate the ion separation. Then you produce a condenser phase charge separation. When it happens, the ionization occurs. This is called soft ionization. You want to see a picture? I'll show you. You see, this is my sample embedded in a light absorbing matrix. A laser beam strikes the surface. It excites the molecules. In the process of excitation, sample distortion occurs and your compound is getting protonated. It becomes M+1. The matrix I use for proteins, cyanoic acid, DHB, that is dihydroxybenzoic acid, and so on. If I use a peptide, I use 4-hydroxy, cyanocyanic acid, etc. Therefore, and by using a matrix, it is possible for us to get the mass spectrum of a protein intact. A protein molecular weight can be as large as 180,000 Daltons. A small molecule, a pharmaceutical molecule, drug substance can be less than 1,000 Daltons. You can cover entire range by mass spectrometer by this kind of ionization process. Good. What is time of flight mass spectrometer? Very simple. Your high school physics. Velocity is equal to distance traveled divided by time taken. This is the ion. It travels this distance, hit your electrode. How much time does it take to hit the surface? You measure that time of nanoseconds. Then use this formula and you can measure the distance. M by Z is related to the velocity. That's all. I do not go into full electronic details of this. This is a typical mass separation that happens in a MALDI-TOF instrument. And this is a typical MALDI-TOF mass spectrometer called Axima. This is a particular model of a manufacturer company. Good. Now what happens? I have discussed different ionization sources and also I have shown you what is the process involved in ionization. Then in liquid chromatographic and mass spectrometry, your APCI, ESI are the one where you do charged droplets, proton transfer plays a role. In the case of MALDI-TOF, photon absorption plays an important role. Therefore, this is how the ionization occurs using various techniques. Next is analyzer. Very quickly, we'll see analyzer. There are several analyzers available. I will talk about only one analyzer depending upon the time availability. One is what is called quadrupole mass analyzer. But it's called, that is what many of the triple quadruple mass spectrometry, most of you using it. And there you use quadruple mass analyzer. You can also use an ion trap analyzer. You can use also orbit trap mass analyzer, depending upon your applications. Now, but to start with, I will talk about quadruple mass analyzer. What is a quadruple mass analyzer? My compound has got ionized, entering into the ionization region to an analyzer. There, this is how the ions are entering. What I have done here is, I have got 4 molybdenum rods arranged in a hyperbolic geometry. Now what happens when I apply a DC voltage, I apply a variable AC voltage of frequency omega or F. When this enters here, now what happens? Depending upon the AC voltage, DC voltage and the AC voltage and the frequency, I can decide molecular ion or filtered out. Therefore, quadruple mass analyzer is called a quadruple filter. So equation is now 350 times omega take. What is this here? All these equations. I don't like this. I know you also don't like this. Remove this. You see this picture. It's a beautiful picture. It is drawn by me. That's why it's very beautiful. Why? I have kept a ball here. It's a very peculiar frame of reference. If we imagine this frame of reference in a 3-dimensional angle, the frame of reference is such that either the ball will fall on this side or the ball may fall on the other side. Unstable. It's not stable. We will do an exercise. You rotate this frame of reference slowly, very slowly. Slightly increase the speed. In such a way, the ball is stable. When the frame of reference is stationary, the ball is unstable. Either it will fall on the one side or the other side. Now I am going to rotate the frame of reference. Now the ball becomes stable. Remove this ball. Put another ball, say M2. Again rotate the frame. The M2 ball is stable. Keep another ball, M3. Rotate the frame of reference. The ball is stable. For every mass of the ball, M1, M2, M3, M4, M5 and so on, you will come to the frequency F1, F2, F3, F4, F5. Therefore, the rotational frequency of the frame of reference is related to the mass of the ball. Now you see this equation. The mass of the ball is related to the frequency of rotation. The frame is nothing but the electrical field you created because of the DC and AC voltage. Depending upon the frequency M1 will come out. F2, M2 will come out. M3, F3 will come out. M4 will come out. In this case, you can see, in this case, F3, M3 has come out. Therefore, the frequency by rotating, by changing the electrical field, variable electrical field, I am trying to get mass one by one out. That is why it is called mass filtering. One mass at a time. I filter, take it out. Filter, take it out. I am using 4 rods, quadrupole. Therefore, in a quadrupole analyzer, all the ions are separated. Fantastic. Very good. I understood the quadrupole rod now. Now, This is a typical quadrupole rod. This is now, what is ion trap? Now, you produce the ions and you produce the analysis. Analysis, ionization, both occurs simultaneously in this place. If I have kept 4 rods, it's called ring electrode. I produce the ions here. Simultaneously, they get analyzed and they enter into the ion detector. Therefore, ion trap is one. You trap the ion, detect it. Very simple. I will not go into technical detail because same as a type of quadrupole, except that design is different. Next is orbit trap. Very simple. What does it do? You produce the same quadrupole kind of situation, but what you do is you produce what is called orbiting motion around the central electrode and simultaneous oscillation in the Z directions. Sir, how can we do that? This picture will tell you. You see, this is the curved electrode. This is the electrode. It can undergo a simultaneous oscillation. When it has a simultaneous, the spindle-like central electrode, barrel-like outer electrode. This is a barrel, this is a spindle. Both are there. Both, one is a Z direction, another is a X direction. When it happens, the orbital motion around the central electrode and simultaneous oscillation in the Z direction produces the ions getting separated. That is how, that is why it is related to mass, is related to frequency. This is an orbital mass spectrometer. Analyzer works. What is a detector? Very simple. Electron multiplier. What does it do? This electron multiplier. What does it do? It is used to detect the presence of ion signals emerging from the mass analyzer of a mass spectrometer. It is the eye of the instrument. The performance have an influence on the overall performance of the mass spectrometer. Each ion, each molecular ion that is analyzed by the analyzer is getting detected by this electron multiplier. I got the signal. Fantastic. We have entered into the mass spectrometer as a sample. We are now coming out of the mass spectrometer as a mass spectrum. This is a detector which does this job. A signal is out here. Very good. What does a signal look like? You get a positive ionization, a compound of mass spectral value 329, M+1. Sir, now many people offer negative ionization. That's what is that? Are you getting a mass spectrum of negative ionization? The answer is yes. You are getting 327, negative M-1. You get M-1, 327. You get M+1, 329. Therefore, my molecular weight of my compound is 328. This is a typical mass spectrum of an unknown compound. Why it is unknown compound? I do not know what it is. I got 329, I got 327. Therefore, I understand that from the spectrum, it is 328. My compound has entered from a liquid chromatography into a mass spectrometer through by forming a mist. I removed the mobile phase. I got it soft ionization. I got M+1. My supplier of the instrument has said it has got negative ionization. Though I do not know what it is at this point in time, I am able to get a negative ionization, M-1 also, M+1 also. I got both the ions coming here. It passes through a quadrupole mass analyzer. Afterwards, entered into a electron multiplier. It got detected. I got a spectrum. A nice tool. What is the spectrum? How to understand this? How to interpret it? next lecture. Thank you all.
One second. Hello? Yeah.
Hello.
Yeah. Thank you, sir, for the very incisive masterclass on mass spectrometry. Starting this tour with the sample nature, the basic criteria that has to be met for ionization, the different ionization techniques in LC, GC, and its effects and processes, and of course, the MALDI for all the large molecules like proteins. You have just taken us through a suite of, all the mass spec options that are, available today. But it looks like a single session is not enough to, to kind of cover the entire basics of mass spectrometry. So, do we have another session? Like a part 2 on an MS tool?
I can do that. We'll plan how we can do that. We'll plan.
Okay. So now we will have a poll of 3 questions. That is kind of related to what we have learned. Yes. So the first question is 1. The electron spray ionization produces option A, M+1 ion, adduct ions of the molecule, M+1 ion and mostly adduct ions, or D, molecular ion only. Please select the best possible answer according to you. So we can have just 1 minute for the poll, or sorry, like maybe 30 more seconds, and then we can close the poll for the next question. So can we close the poll now for the first question? Okay, so 50% of the people have gone for the M+1 ion, and we have M+1 ion and mostly adduct ions at 29%, and molecular ion only at 16%. And of course, 4% of the people have answered that the adduct ions of the molecule is one of their options. Sir? Sir, you're muted.
Yeah, M+1 ion and most adduct ions would form in the electron spray ionization technique.
Okay. So next we can go on to the next question for the poll. So can you flash it, please? Yes. So this is for the quadrupole analyzer. So the quadrupole analyzer, so the option A, it filters mass ions. Option B is a high resolution analyzer. Option C, it produces multiple ions. And option D, detects ion current. So which one will it be? So let's have 1 more minute for this poll question as well. So can we close the poll now? Sure. So can we close the poll now for the third question? Yeah, so let's see the result. Yes, 55% of the people have opted for the filters mass ions, and we have 24% for is a high resolution analyzer, and 18% for produces multiple ions, and 4% for detects ion current.
Yeah, filters mass ions then.
Sir, so why isn't it like a high resolution analyzer? Since like 24% of them have opted for it.
they talk, say, when we talk about high resolution, should be less than milli-Dalton. Nowadays, many mass spectrometers with they point on atomic unit itself, they call it as a high resolution. That is why some of them would have polled like this.
Okay. So can we have the third question for the poll, please? So the MALDI top is a unit resolution MS, that's option A. Option B is a high resolution MS. Option C is high resolution and large molecule analyzer. And option D is a laser instrument. So let's have 1 minute for this question as well. Yeah. So the poll results are out for the third one. Okay.
That's correct.
The people have gotten it right with the high resolution and larger molecular analyzer, like, you know, if you want to analyze protein structures. Yeah. And of course, laser instrument, 26% of the people have also gone for laser instruments.
Because it uses a laser, they thought it can be a, the answer is not wrong, it's right answer. But the most appropriate answer is the third one.
Okay, so the most appropriate is the third one. Okay. So that will be the poll. And now we'll start taking the question and answers. So, okay, so we have Bharat Kumar who's asking us, hi, sir, can you please share about what is centroid and profile mass in mass spectrum of LC-MS?
We'll do that. When we talk about the interpretation of the mass spectra, we'll talk about that.
Yeah, because I think we are having two or three sessions on the qualitative and 2 sessions on quantitative.
Yes.
Yeah, we have a lot.
The qualitative analysis will talk about the centroid as well as the vertical line.
Yes. Okay. So that will be answered in the subsequent sessions. Sorry. So then we have one more from Nageshwar Rao, and he's asking, so LC to MS convert chart, is it available? So
available. The chart is available. We'll share in our next presentation.
Okay. So one more anonymous attendee. Is triple quadrupole suitable for impurity identification and structural elucidation?
Yes, suitable.
Okay. Because I think that is what we were talking about, the qualitative analysis. So yes, we'll be having I think like one of the next few sessions is going to be about qualitative analysis using the LC-MS.
Correct.
Yes. And okay. So Ashmita Dinmar is asking us how to analyze crude extract to identify microbial secondary metabolites.
You have to sample preparation plays an important role there. You have to do the extraction very well, otherwise it will contaminate the mass spectrometer.
Okay. So we have Praveen Kumar. So he's asking us, what about 409 in positive and 373 in negative in unknown sample?
Pardon?
So the question is, I think, yeah. So he's gotten 409, the mass charge in positive, and he's gotten 373 in negative. So this is for an unknown sample. So I don't think we have any information about the structure in this case.
No, both the peaks, both negative, the peaks are different, the ions are different. That you have to look for other aspects for interpretation of the data, which we'll discuss in our next session.
Okay. Yeah. And we have one more. Okay. So as the analyzers are sensitive, then why we have to go for advanced analyzers like QTOF?
QTOF is not a sensitive instrument. QTOF is an instrument for high resolution or accurate mass analysis.
Okay. So we have one more anonymous attendee, and he says, okay, how to measure the compounds having more than 2000 Daltons using triple particle?
You have to look for that. When we discuss, we will discuss about what is called how multiple charge ions you should look for. Multiple charge ions you should look for.
And I think there's also a software called the deconvolution software that helps with that. Yeah. And the next question is, okay, where is it? Okay. Thank you very much for a very, it was very, very formative. Could you please tell us the use of internal standard in LCMS?
Yeah, when we do quantitative analysis, we'll talk about that.
Because it looks like a lot of the questions are for the subsequent session we're going to take. And okay, yeah.
The subsequent session is going to be more interesting.
Exactly. Yeah. Can you explain the jet separator 2 minutes only? So I think he just wants just more information on the jet separator.
See, in the case, jet separator is used for packed column gas chromatography, where the flow rate is 30 ml per minute, number one. Number two, it is used, and the temperature of the jet separator also should be kept around 250 degrees centigrade. Therefore, you have to use a special glass of jet separator. And there are methods of connecting jet separator to your packed columns. There's different methods available. You should connect accordingly. Since nowadays most of the gas chromatography people use only capillary GC, I did not spend much time on that.
Yeah. So like one more question. So which analysis requires the APCI ion source?
APCI, mainly for fatty acids, non-polar compounds.
Okay. And the next one is which all matrices for MALDI? So
the list of matrices, there are more than 25 matrices are there. We can share that list. Literature is available.
Okay. Okay. So Siva Lakshman Rao has asked us, in optimization time, while using union for optimization, I got peak in reverse direction.
That is because of the compatibility of the mobile phase. Usually he will get a negative peak, right?
Yeah, because that's what he says, yes.
Yeah. Because of compatible mobile phase. And again, there is one more reason is the polarity switching you have to check in the system.
Okay. When are you doing on analysis and interpretation? Okay, that we will share in our subsequent, in our LinkedIn. So it is like a series, and now we are in the basics. But I think it will either be a month or like 2 months in. So yeah, that's my question. Okay, so what is SIMS secondary ion mass spectrometry? That is
what is called SIMS, huh?
Yeah.
Surface enhanced ionization technique. It is, we will not, in my presentation, I have not covered that. That is actually mainly used for various other applications, such as fatty acid analysis in many of the biological applications, which I have not covered here.
Okay. And how to differentiate mass fragmentation and M/Z ratio?
When we interpret the MS spectrum, I will explain that.
Okay. And okay, hello, sir. In the case of double MS, every step in MS will repeat again. If it is yes, then what about the sample loss?
See, mass spectrometry is basically a destructive technique. Once the sample enters, you lose the sample. That was only once. There is no reproducible. There is no need that you have to repeat the analysis again. There is no need, unless the instrument generates some artifacts.
Is it possible to perform quantitative analysis of unknown compounds without standard available?
You can do that. Provided you know how to use, you can do that.
Okay. Yeah. And is it possible to measure the molecular weight of heavy, like glycosylated protein on MALDI-TOF MS?
Yes, you can do that. That's not a problem.
Okay, so it's not a complicated sample to analyze on the MALDI?
Yeah, it is a complicated sample, but there's a method of there's a separate method of sample preparations involved. Then you can do that.
Okay. And Mr. Dashrath Patel has asked, is both form of ions produced in electron ionization, both means positive and negative? Yes.
What is the question?
Okay, he's asking if both forms of ions produced in electron ionization. So both electron positive, if both positive ionization as well as a negative ionization takes place.
I'm not understanding the question.
Yeah, because I'm not able to understand. But I think, see, the thing is we can do both positive as well as negative ionization.
We can do that.
So the next one is, how can we identify unknown compounds if we already developed HPLC compatible method like a strong buffer as a mobile phase?
You have to modify the mobile phase.
Because if it is TQMS, then we have to definitely...
You have to make it compatible with the mass spectrometer.
So the answer to the question is we need to convert it into an LCM.
Volatile buffer.
Yeah, volatile buffer. And, okay. How can I determine the purity of an isolated compound?
All next lectures. This will come in the next lecture.
I think a lot of the questions are basically for the next lectures.
Yes.
So you guys need to stay tuned. And so we have a few more questions, sir. What are the signs of mass spectrometer contamination?
If a sample preparation plays very important role in contaminating the mass spectrometer.
Okay. And once again, yeah. So kindly, sorry. So can oil and water, okay, how come I'm not able to see the thing? Just one second. Yeah, so can oil and in water emulsion be tested in LCMS?
It can be tested, but you have to use a miscibility solvent between oil and you have to use a surfactant as a solvent in order to dissolve this oil in water.
Okay. And then we have one more question. So actually we have a lot more. What is monoisotopic mass and doubly charged ion?
See, monoisotopic means that the C13 peak does not appear there. C13 peak. Doubly charged means it will be, if it is 300, it will become 300 into 2m will come, so doubly charged peak it will come. 600 will get another peak.
Okay, I think this is from the LinkedIn question, the poll question that we shared yesterday. And so we have one more person asking us, kindly explain how important it is, how important is tuning files for LCMS techniques? How it is important?
It's very, very important. That is what it has a calibration, which is a sensitivity. Therefore, tuning is the most important information. When we talk about how to optimize a mass spectrometer, we'll talk about how to tune them. We'll talk about that.
Yeah, I think we have an entire session that is just for the tuning, because that is basically, as sir mentioned, the calibration that you do for the MS.
Yes.
And okay, What type of ionization technique is better for impurity identification?
Generally, electron spray ionization is the best technique.
Okay.
And MS.
Okay. Can we use the same MS for LC and GC? Both?
We cannot.
I don't think we can do it. Sorry. Yeah. And yeah. So Mr. Karthik has said, dear sir, I have analyzed some of the synthesized organic molecules using ESI-MS, but I observed M minus H20 peak pattern instead of M plus H peak. Is it possible, or how can I solve about, okay, so how can I solve it? He's written it.
He has got M23 peak, M plus 23.
M minus, yeah, MH20 plus, sorry, MH, yeah, actually it's water, yeah. H2O, yes. But I observed MH2O peak pattern instead of M plus H peak. So I think it's got a water product.
No, what does he want?
Okay, dear sir, I have analyzed some of the synthesized organic molecules using ESI-MS, but I observed an MH2O peak, with
that water. That is possible. That is adduct formation. That's adduct formation.
Okay. Is it possible, or how can I solve it? I think he wants only the M plus H.
Now you have to change the mobile phase.
Okay. Is there any way to reduce adduct formation? I think this answers the question.
There are several ways by which you can reduce adduct formation.
How do we do qualitative analysis in LC-MS? Again, that is like a separate session that we are going to talk about. And of course, up to how many molecule? Okay. So what is the molecular weight limit of for mass spectrometry? Sir?
What is that?
So what is the molecular weight limit for mass spectrometry?
So it's a quadrupole, it is around 2000. If it is a MALDI of things, you can go up to 300K, 400K like that.
Okay. Can two different compounds fragment in the same pattern? If no, why?
These questions we can answer only in the
qualitative session.
We talk about the isomer analysis, application.
Okay.
So probably what I request you generally is to skip the application questions. Don't reserve it for next.
Yes, sir. I'll do that. And
anything regarding instrumentation, what we talked today, anything related to instrumentation, I will answer today. Okay. Applications only next session.
Sure, sir. Which is best for work, HPLC or MS or LC-MS?
For what, which work?
Yeah, exactly. Which work is that? So actually it depends on the work that you're doing. And okay, how much peak intensity will be considered as, okay, that comes under that. Okay, how can we do relative quantification of, okay, that is also that. Okay, when will we conduct the next lecture? It will be next month. We will provide you the information. What is the role of EMT, sir?
Huh?
What is the role of EMT?
That is acts as a detector.
Okay. Okay, does MALDI-TOF give complete protein M by Z value or M by Z of fragments of the protein?
It gives you, mostly it will give you the M by Z value of the protein.
Okay. And in precursor ion scan, the negative mode MRM collision energy is not accepted. Why? Okay, that is, I think we can have that for the next session. And okay, a lot more on that. Is resolution, okay. Is resolution an important parameter of MS method?
Yes.
Okay, and, okay, a lot of this comes for the next session because, we have a question asking us, how can we identify main mass peak in mass spectra if there are a lot of peaks?
Next session.
Next session, okay. Okay, please describe the difference between hard and soft ionization in few words. I'm a little bit confused here. It's my humble request. So it is from Mr. Rana.
Yeah, soft ionization is one where you are able to see the molecular ion intact. Hard ionization is one where you are not able to see the molecular ion.
Okay. In the LC-MS-MS and GC-MS-MS, okay, like out of these, which technique is best for quantitative analysis? So Mr. Ram Singh has asked us this.
No, next question. No, it is very difficult to answer. This is not the right question.
Because I think that depends on the sample and everything and the sensitivity that you want. And this is a general question. What are the things we need to keep in mind during buying HPLC? And what are the infrastructure that we need to arrange to keep the instrument in the room?
They have to ask the supplier, not me.
Maybe he's asking you for your opinion on what kind of HPLC you would choose.
No, I will not answer.
And of course, okay, that is a very, okay, so we have one more. Okay, most of these, so I think rest of the questions are also kind of related to the next session. So that will be all the questions. And so I think a lot of the questions in this session, I think we've had around 50 questions at least. And most of that was related to either qualitative or something to do with method development and everything. And all of these sessions, we will be slowly covering in the upcoming months. So it will go on with qualitative sessions, probably 2 to 3 sessions on qualitative. And of course, then we go for quantitative. And then, of course, how we can maintain the MS. So we are going to cover the entire MS, mass spectrometry domain. And this will be followed by applications. So stay tuned with us for the subsequent sessions if you want to learn more. I think that will be all, folks. And thank you very, very much for the overwhelming response and participation that we've got today. And so we will have the next part on the mass spectrometry basics in the next month. So stay tuned on that. We have also shared with you 2 documents. One will be the suite of suite of solutions that Shimadzu has to offer for the various samples and the requirements that is needed, and also a booklet that is basically talks about the fundamentals of mass spectrometry. Both of which have been shared in the chat box and the Q&A box. In the chat box. And please do read that for your further study. And if you have further questions on anything, please do share with us at sharingthelearning@spinfotech.com. I'll just make sure that it's linked in the chat box right now. And for more information on mass spectrometry or any questions, please do feel free to reach out to us. So let us uncover, understand, and unleash the full potential of the mass spectrometer. So let's meet next month for another session of Sharing the Learning webinar series, and of course on mass spectrometer. Thank you so much for the participation and all your questions. We will keep these questions here. And so what we can do is we will also make sure that we can filter the questions. And when we are doing that session, and if you're there, we will also make sure to answer those questions live in the subsequent sessions. So thank you very much. And that would be that.
The fragile microscopic matter that guides us towards new avenues of research, stretching beyond our imaginations. Beginning in 1970, with the release of Shimazu's first mass spectrometry instrument, a magnetic sector mass spectrometer. Through half a century of advancement, including the development and integration of gas and liquid chromatography methods and ionization methods such as MALDI, Shimazu's MS instruments have become recognized as a powerful tool at the cutting edge of scientific knowledge. In the field of healthcare, for example, Shimazu is working to build a future in which health conditions can be predicted with great accuracy. The results of Shimazu's inquiring spirit and unceasing endeavors can be seen impacting the lives of patients in diverse ways. Pursuing our vision for the future of mass spectrometry. Compact.
I'd like to have a versatile pocket MS for use in remote areas.
Simple.
The power of mass spectrometry will be made easy for the non-expert user in the clinical laboratory. This will help to support precise and early-stage diagnostics.
Intelligent.
I want to make a super intelligent MS, taking advantage of AI technology.
We continue to challenge ourselves, inspired by a future filled with endless possibilities. Celebrating 50 years of MS innovation.
So thank you once again for participating in the 5th session of Sharing the Learning webinar series. And like as I mentioned, we have the brochure as well as the fundamentals booklet in the chat box. And we will also be sending you an email with your certificate and these documents as well.
Of research, stretching beyond our imaginations.
See you next month.